Hello students, today's topic is superheterodyne receiver. So student, this is the block diagram of superheterodyne receiver. There are mainly 5 stages. First stage is RF amplifier, second stage is a mixer, third stage is IF amplifier. IF amplifier is intermediate frequency amplifier. Then there is a detector or a demodulator. And last stage is audio voltage and power amplifier. We will discuss all the stages one by one. Here we have connected one antenna, incoming electromagnetic wave received by this antenna. Antenna will convert electromagnetic wave into electrical signal. First stage is RF amplifier. RF amplifier is a class C amplifier. Class C RF amplifier not only amplifies our incoming signal, but there are three main purposes of using this RF amplifier. First purpose is to reject image frequency. Second purpose of RF amplifier is to provide better sensitivity by increasing signal to noise ratio. So RF amplifier increases signal to noise ratio, and by increasing signal to noise ratio, it increases sensitivity of circuit. And third purpose of RF amplifier is to reject unwanted signal. So if any unwanted signal is there at the input to RF amplifier, it will reject that unwanted signal. Then second stage is a mixer. We have connected one local oscillator to this mixer. Suppose input to this mixer is Fc and the frequency generated by local oscillator is Fl. Then various possibility here, like Fc could be equal to Fl, Fc could be greater than Fl, or Fc could be less than Fl. So suppose if Fc is equal to Fl, this condition is known as synchronous detector. But if Fc is not equal to Fl, if Fc is less than Fl, or if Fc is greater than Fl, this condition is known as heterodyne condition. But here generally we maintain Fl greater than Fc. So Fl greater than Fc condition is known as superheterodyne condition, and that's why this receiver is known as superheterodyne receiver. Since in superheterodyne receiver we always maintain Fl greater than Fc. So output of mixer could be the difference or the summation of incoming frequency. So output of mixer could be Fl plus Fc, or it could be Fl minus Fc. But by using one band pass filter here, after mixer, we will generate only Fl minus Fc signal. So our Fi or intermediate frequency will be equal to Fl minus Fe. This intermediate frequency feed to a IF amplifier. IF amplifier is an intermediate frequency amplifier. Purpose of IF amplifier is just to amplify intermediate frequency component. IF amplifier is a fixed frequency amplifier. No matter what the incoming signal frequency is, same signal is now available at IF amplifier. Whatever is the incoming frequency, same frequency will be available here always. Since it is easier to design an amplifier of fixed frequency, it increases selectivity of our amplifier. So we generally maintain 455 kilohertz frequency as the intermediate frequency in case of superheterodyne receiver. After IF amplifier, there is a detector or a demodulator circuit. It is a AM receiver, so we will use any AM demodulator like envelope detector here. Envelope detector circuit will produce message signal or baseband signal from intermediate frequency signal. So output of demodulator circuit will be our baseband signal or message signal. And after that there is a audio voltage and power amplifier. Purpose of audio voltage and power amplifier is just to amplify message signal. Features of receiver. There are three main features of receiver. First feature is selectivity, second feature is sensitivity, and third feature is fidelity. So first feature is selectivity. Selectivity is ability of receiver to select desired signal and reject unwanted signal. Selectivity means to select desired signal and reject unwanted signal. Suppose there are three signals which are coming to our receiver. One is at 98.2 megahertz, second is 98.4 megahertz, and third one is 98.6 megahertz. But we have designed this receiver for 98.4 megahertz. So our receiver should able to reject other two signal, like our receiver should able to reject 98.2 and 98.6, and it should select 98.4 megahertz. Selectivity depends on quality factor Q. Q is equal to FC upon bandwidth. So we generally fix our center frequency at 455 kilohertz to maintain better selectivity. Second parameter of receiver is sensitivity. Sensitivity level tells us the weakest signal that a receiver will able to identify. Or we can say sensitivity is the ability of receiver to pick weak signal and amplify it. It depends on gain of amplifier. If gain is better, sensitivity will be better. High gain means good sensitivity. Third parameter of receiver is fidelity. Fidelity of receiver is the ability to reproduce exact replica of transmitted signal at the receiver output. In other words, we can say that ability of receiver is to reproduce all the frequency component of message signal. So we can reproduce original message signal as it is. That ability is known as fidelity. To avoid the distortion in the receiver signal, fidelity should be high. Means better fidelity means no distortion. Without distortion, we are able to produce message signal. Thank you.